Hello and welcome to chapter 39 of this Flutter course. In the previous chapter, at the end of the previous chapter, we talked about that. In this chapter, we're going to talk about the Bloc library. And this is quite a hot topic for Flutter developers. Like if you're a Flutter developer and you've just been using vanilla set state, in your application, you may have already heard about Bloc library and qubits before. If you're not a Flutter developer from before, which I actually think the majority of you taking this course probably have not been Flutter developers from before, so you may have not heard about Bloc before. So I'm just going to start this chapter by explaining what the Bloc library is and why do we need it. You see, the way that we've created our application at the moment is that we have direct calls from our UI code into our different services in order to interact with data. So the UI is very well aware of the business logic. So, for instance, the create or get existing nodes function that we have when we actually go and create a new node, that is already aware of the fact that, well, if you end up in here, I expect a user to be present inside the application. So a user should be logged in. And that's an example of a UI component being aware of the logic, the business logic of our application. So they should be very separate from each other otherwise, but they're not at the moment. So what is Bloc? Bloc is a library that we're going to drag into our application soon. As you'll soon see, is a third-party library called, I believe it is created by a company called Very Good Ventures, VGV, and there are various Flutter developers and software engineers that are constantly working in order to improve the quality of the Bloc library, which is a dependency that we'll bring into our application. And using the Bloc library, I mean, internally is using streams and stream controllers and futures, the stuff that's already built into Flutter, but it's like going to a next level to make things more abstract so that our application isn't directly dependent on its business logic with the UI intermixed. So the reason we need the Bloc library is just to ensure that our UI is only taking care of the presentation of the UI and it's leaving the rest of the stuff to a business logic layer. Excuse me. So that's why we need Bloc, and we're gonna use it soon in our application. Excuse me. So if that is Bloc, then what is Flutter Bloc? You see, Bloc in its internals is a very simple library that works with streams and stream controllers. So it allows you to, for instance, pass data from here to there and have listeners that listen to changes that are happening in a stream. So it's only working with like very low level stream stuff. However, when you come to your UI layer, as you remember, I mentioned that Bloc allows you then to separate your business logic from your UI. So it's taking care of the business logic using streams and stream controllers and futures. But when it comes to the UI part, in order to glue this business logic with the UI, it needs to be able to work with Flutter. So the part that works with streams and stream controllers using Dart, okay, and Dart asynchronous components. But the part that it wants to glue that with your UI needs to come to the Flutter world, okay? And that library in itself is called Flutter Bloc. So Bloc is divided into two separate libraries. One is Bloc, which takes care of the business logic, etc., and the other one is called Flutter Bloc. All right. But don't worry about it. I'll go through these with you one step at a time, so you'll learn these. Excuse me. So what we're going to do in this chapter is going to have, it literally has nothing to do with our application. We've been working with the Notes app, and in this chapter, we're actually going to break our application a little bit by just like literally replacing the homepage of our application with a completely new application. It's nothing scary. I promise you, the changes we're going to make is probably only going to be limited to the main.dart file. And what we're going to do is to create a counter application. If you've worked with Flutter before and you've started thinking about maybe moving over to Bloc, you may have actually gone to the Bloc library's documentation page and you've seen a counter application in there where you have a plus and a minus button, and you can increase and decrease the value that's shown on the screen. So that's like the basic counter application. But in this example, I'm going to show you, we're going to take that example to the next level and use the Bloc library. And I'm going to introduce all the basics of the Bloc library to you in this chapter. But we're going to take it to the next level and allow the user to enter some value on the screen. And that value will then be able to be added or subtracted from the current value that the application stores. So it's kind of like a counter application where the user can actually enter the value that needs to be added to the previous count, or it needs to be subtracted from the previous count. So that's the difference between our simple counter application and what Bloc library's counter application in its documentation introduces you to. All right, so let me bring up this caption in here, and we're going to talk a little bit about various components of a block. And I'm fully aware that pretty much everything I'm saying in this chapter up to where we get to the example is all very much abstract, in that it is literally just theory. I'm like teaching you theory here. I personally am horrible at theory. Like, I didn't excel at school when it came to theory. So I'm very aware that a lot of you may also have the same situation, or maybe in the same boat that I am, that are not good with theory. And that's okay. I'll just explain these fast and then we'll go to the implementation so you can put that to practice. So for those of you who are interested in the theory of it, I'm going to explain different parts of the Bloc library to you now. So here, the first component of the Bloc library is a class called Bloc. Now, Bloc, really, it is a container. Just imagine a class that you add events to it, and every event that you add to it can produce a state. So the way Bloc works is that it is a class that begins with a state. So its output is always a state. For instance, a state can be logged in, a state could be logged out, a state could be error screen. So just imagine different states of the application. So that's the input, the output. The input to it are your events. So in your block that we will develop, you will have inputs that you, for instance, say log in with this username and password. Register with this username and or this email and password, register. Or I forgot my password and here's my email. So these are events that you produce and give to your block, and then in turn your block then looks at its own internals and say, oh, what was the state before? What is the current event? Then I will produce a new state. Okay, so that's the internal of the block class. Now, when you have a block class, when we're going to subclass from that block class, then you will actually need to create an instance of that block class. And you will do that using something called a block provider. So as its name indicates, it is a class that creates a block instance for you, and then it will allow you to do something with that block. So I'll see if I actually can show you block provider. Perhaps we could bring up a window in here, and I'm just going to say, so block library. You cannot see my screen right now, but I promise you I will show you soon. So here's the main page for the block library. So I'll increase the font size so you can see it as well. So let's go ahead, and you can see it's sponsored by Very Good Ventures and Stream and Miquido. I'm not sure. I may have butchered this name right now. I apologize for that. But then if you look at the various parts of a block, then you'll see, let's see if I can find block provider for you here. It could be inside the documentation. So I'm going to go to get started, and then I'm going to have a look at block, package block, and let's see provider, if you can find the provider in here somehow. Block, architecture, naming convention, getting started. Is something inside? I have a little bit of a problem right now actually finding block provider. So let's search for it, block provider. And then we end up here. And I mean, this is not the best documentation right now, to be honest with you. We don't want to look for a block provider right here, but as you can see, it says it is a Flutter widget which provides a block to its children. So this is how you would work with a block provider. So it creates the block instance for you, and then it will allow you to return a child. All right. So kind of like a builder, but not really. All right. So that's a block provider. And as I mentioned, you can always go to the blocklibrary.dev website in order to get more information about Bloc and read its documentation. So the next component you need to know about is Bloc listener. So what is a block listener? As its name indicates, a block listener simply allows you to hook into I'll actually see if we have a block listener. I can see that we have a block listener in this application that we're going to develop, so you're going to learn about it soon. But a block listener, as its name indicates, it listens to changes to the states of a block. That's it. So you can do some side effects. So displaying a new screen, for instance, or displaying an error message. Those are all side effects. Okay, so you can do that with block listener. Now let's have a look at what a block builder is. Uses your block state changes to provide you with a widget. So as we have a block provider, we talked about block provider before. It gives you the chance basically to create a child. Now, inside this child, you can then create a block builder that listens for changes inside your block. Then it allows you to build new widgets based on those changes. So it's very much like a future builder or like a stream builder, I would say. And we've already used stream builder, so you should know how they work. But again, this is just theory. So I'm going to talk more about these as we actually build our application. Okay. So after all of this, we also have a block consumer. And what a block consumer is that it combines, as I've actually written here, it combines block listener and block builder. So a block consumer listens to changes that happen inside a block, and then it will allow you to do both a side effect, and it will also allow you to create a widget to display to the user based on those changes. All right. And again, I don't want to go too much into details for theory, because depending on how you learn new things, theory may not be your strongest point, just like it is not for me. So it could be a waste of time for you. So let's go ahead and start adding our dependencies in our project. So I'm going to bring our notes application to the screen, resize it a little bit so we have place for strcpy as well. And we have strcpy right here, as I can see, and this is our application. Okay. And the application is running currently. So then what we're going to do is going to go ahead and say Flutter pub add block, and then Flutter pub add Flutter block. So let's go ahead and increase the size in here. Then I'm going to go to terminal, say Flutter pub add block. So that's going to do its work. And it added one dependency. I'm just going to say Flutter pub add Flutter block. All right. And this is a package, so it's not really a plugin. I don't believe it's a plugin. I think it's a package. So it could be sufficient for us just to stop our application in here and just say Flutter clean. That cleans the application. That we're going to say Flutter pub get. This could be sufficient. So that's going to do its work. And then we're going to go to our main Dart file and just say run without debugging. And that's going to just do the Gradle build if you're running on Android, or it's going to use Xcode build in order to build your iOS application. So, and I'm just going to let that do its thing now. So let's just wait. Okay, now the build is done and I can see the application running on the screen without a problem. So What we need to do as the next step is to do something dramatic, and that is to comment out our home page, because we're going to replace our home page with another home page, which is going to use Bloc. So it may sound scary, but it's not that scary, I promise you. So let's go into your main Dart file in here, select home page as it stands right there, and just comment it out. And we're going to create a new stateful widget again, and we call it homepage. So STF and homepage. The reason this is a stateful widget is because we need a text editing controller. As I mentioned, how we're going to do this example right now to learn Bloc is to create an application that gives you a text field that you can enter a number into. We start with the value of 0 in our block, so the block holds on to a number, and then we will create two events, one an increment event and a decrement event. And so when we then give the increment event to our block, then we want to grab the current value inside the text field. So if we start with 0 and then I type 5 in this text field and I press the increment button, then I want 5 to be added to the current state, which is 0. So the result will be 5. The next time I will type 10, then press decrement. So decrement will be 10, and then it will be 5 minus 10. So we end up with minus 5. So that's the UI that we're going to create. And for that, we need this home page. And the reason it's stateful is because we need to grab that text from our text editing controller. Okay, so that's our new homepage. And if I now press Command S in here, our screen is going to be black because, well, this is a homepage with no information, no scaffold, nothing. All right. So, and now let's talk about this absolute beauty that we're going to call counter state. You see, as I mentioned, every block has two very important properties. One is its state, and the other one is an event. An event goes in the block, and state is something that comes out the block. And so the state, as its name indicates, describes the state of your block. So if you think about it, what we expect from our block is a simple integer. Okay, so we could either say our block's output is integer, or we could define a state that wraps around that integer. So that's exactly what we're going to do right now. So let's go ahead and say we have an abstract class, and we call it counter state. And in here, we have a final integer called value. And then we're going to create an initializer here like that. And that's our counter. You could also mark this as immutable if you want to. All right, so let's do that. And let me also change the screen layout a little bit here so you see the code better. So that's like the basic state of our block, okay? We're not actually going to use the state as it is. We're going to create two substates for this, as you will soon see. Now, since we're going to create a text field in the middle, kind of like this screen, the user is able then to enter pretty much any text in this text field. Let's just assume. So just normal text, not even integer. So the user could just say hello world and then presses the plus button. What should we do in that case? Plus button, adding hello world to the previous value of 5 means nothing. So we're going to divide our state into a valid state and an invalid state, and then present this to the user in two different ways. So let's go ahead and create a class called, as I've mentioned there, counter state valid. So I'm going to actually grab that code so we don't have to type it ourselves, as you'll soon see. Here we have a counter state valid extends our counter state, which is this one. And we have a constant constructor that says, okay, give me a value, a valid value, and then I'm going to call my superclass with that value. All right, so that's a valid state. Now, let's then create an invalid state. So let's say class. I'm going to bring the correct caption as well. Invalid state, let's say counter state invalid number extends counter state. So in this case, we want this state to actually include some sort of the value that actually made our state invalid. So I'm just going to say that value is a string, and we're going to call it invalid value here, okay? And I'm going to say const, and let's just create an initializer here. Create a few required parameters in here, and we're just leave it like this. So in this case, we're going to create two required parameters. One is the invalid value that caused the error or caused the state of our block to be invalid, and the other one is going to be a required parameter of the previous value. So because we may actually need the previous value, uh, or maybe like the UI needs to display that to the user. So if this is the output of our block, the state, remember, is the output, maybe then the UI actually, upon me trying to plus hello world with 5, it may want to use this previous value to populate that text field or populate the UI again and say, hello, this value that you entered is invalid, but the previous value was this. So I'm just going to show that. Okay, so that's why we need previous value. And here we're getting an error because we're not calling super. Let's call super with the previous value. Yes. Okay, that's our counter state invalid number. Okay, so we've created our two states that come from counter state immutable abstract class. Okay, let's go ahead then and create our counter event. And remember, counter event is very similar to state. So first we actually have to define an event. And let's go ahead and define that event like this. And you can see it's an abstract class called counter event, and it just contains a value. So it just says the string that comes from the UI can just go directly into the counter event. That's it. And let's make this actually immutable as well. Okay. And what we're going to do is to create an event for increment. So let's go and say class increment value for increment event extends counter event. Okay. And in here, we're just going to say const, create a constant constructor for it. And we just grab a value in here. So a string value, and it should just go to the super. That's it. And what we need to do is just to grab this event as well and create a decrement event. So let's call this decrement here. Like this. So, and again, remember, the event is something that we need to trigger and send to the block from the UI. All right, so we're going to pack these increment event and decrement event with the string that the user has entered in the UI and then send it to the block, as you'll soon see. So let's go ahead now and do the main part of this application, which is our block. And the way to do that is to create a class, if I can spell class, and say counter block extends block. And you'll see it'll now auto import it for me because we hadn't imported block from before. And now let's see if block is imported somewhere here. And that's the package block. If your editor doesn't allow you to auto import, you will have to do that by hand. Excuse me. So the way to create a block is first you define the state of that block, like what type of state does it have, and events. First, we start with the counter event and then the counter state. Okay, so if you look at the definition of block class itself, you can see the two parameters are, or the two generic types are the event and the state. So that's here we're saying our events are of type counter event, and our states are of type counter state. So that's that. Then let's go ahead and say we have a counter block. That's the constructor. And what it does is it has to call super. You see, and our super actually needs the initial state. So every block has to have an initial state, and that's when you need to pass to your super. Okay. So what we're going to do is we're going to say we start with the value, a valid value of 0. So we say const counter state valid, and we start with 0, just like that. Okay. So that's our, let's see what happened there. Seems fine to me. Yep. Okay, so that's the initializer in there. Now, what we need to do is actually grab these events as they come. Remember, the UI is going to basically pass us these events. So the UI is going to say, here's an increment event with this value. Here's a decrement event with this value. So we need to catch those. How do we do that? There is a function called on on the block itself that you can use. So we're going to say on increment value, increment event. And then it gives you two parameters. So if you look at the function signature of on, it actually gives you, you see, it gives you the event and an emit. So let's in here just write event, emit. And in here, we create a new function and put semicolon at the end. So that's how we're going to handle the increment value. Same we're going to do for decrement. So let's just copy that and paste it in here and just say decrement. All right. So what are we doing here? Now, remember, the event that comes in now is an increment event because we literally said on increment event. So we're then going to get that integer from our events. So remember, our increment event actually has is of type counter event, and then it has a value of type string. So we're going to try to parse that as an integer. Okay. So we're going to say final integer is int try parse, and we're going to say event dot value like that. So, and try parse is a function on integer that will try, as its name indicates, is going to try to parse a given string and try to make it an integer. And if it can't, then that integer is going to be null. So let's say if here, if integer is not null, like that, and then we put an else in here, then in the case of an else, actually, so it means that, hey, you gave us something that we couldn't parse as an integer. What do we do with it? All right, then we're going to use our emit. And emit is a function on its own. You see, it's an emitter that allows you then to pass a state out your block. So I actually scared myself with my own finger. So you got your this event in. Now you want to create a state and pass it out. That's how you do it with emit. All right. So we're going to then say, in this case, if we got if actually let's do integer null. If we got null, we're going to handle the error here. Sorry about that. So if we got null, what we're going to do is we're going to emit a counter state invalid number, and we have invalid value and a previous value. So the invalid value was this value that was passed to us in here. You see event value. So let's just say that's the event.value. And the next parameter is the previous value. And the previous value is always stored inside your state. So let me actually do some cleanup in here so you see the code better. A comma here. So let's see what happened in here. You see we're emitting. So we're sending a state outside our block. So we're saying given an increment event where the value couldn't be parsed as an integer, we're emitting a new state saying that, hey, your value, which was in this event, is invalid. So that's invalid value. And the previous value that we had is stored inside our state. So your block, in all your on functions, you have access to your current state before emitting a new one. All right. So that's the previous value inside state. And if we could actually grab an integer, we're going to emit a new value, a new state, and we're going to say counter state valid. Okay. And we're going to say we take the current value in our state plus it this integer like this. All right. Just like that. So that's for increment. And as you'd guess, decrement, I'm going to remove this comma, by the way, it was annoying me a little bit. And decrement is very similar to increment. So I'm just going to copy this code and remove this decrement one and paste the increment one more time. And then this time I'm just going to change it to decrements like this. All right. And for the decrement, the only thing you have to do is just to change this plus to a minus. And that's it. All right. Wow, a lot of work. So now let's go ahead to our homepage in here. Now we've basically gotten the block down, so the block should be working as we want it to. So let's now go into this homepage that we created in here and create our text editing controller. So for that, I'm just going to say late final uh, text editing controller, and we're calling it controller, as I can see here. Let's go into init state and override also the dispose function. Okay, I'm going to bring the code so you can see it. I'm going to bring it up. So in init state, we're going to instantiate our controller. So this is nothing new. You've already done this before many times. And in here, we're going to dispose of that controller. Fantastic. All right, that part is done. So what we need to do now inside our build function, we're going to basically, we have to create our main UI. So I'm going to bring the caption for that. As you can see, we have to use block provider and block consumer. So in the build function right now, we only have a container. So let's, instead of doing a container, say, okay, we want to create a block, and we also want to just like make sure everything after this return statement has access to that block. So we need the block provider. So let's say block provider, and block provider is in a Flutter block package, as you can see here, and we haven't imported that yet. So let's import that right now. In the create parameter, we get a context. As you'll see, I can get Visual Studio Code to complete this for me. It says, I will give you a context and you'll give me a block back. So I'll say, okay, I'll take the context and I will create a counter block here. Okay, so that's the first parameter. Then we're getting an error here just because we haven't provided a child here. So if I say child in here is a text of hello world, and press Command S, then we see hello world right there. Okay, so in here, our task then is to create a scaffold. So let's create our scaffold just we usually do. And for our app bar, let's create an app bar in here and say app bar. Title is a const. Can't see anything because the documentation is all over the place. Const text, and I'm going to say testing. All right. So now we have a block provider that created an instance of our counter block, and then we have a scaffold with a beautiful app bar displayed on the screen. Okay. So as the caption at the bottom screen mentions, for our child, the child of our block provider is a scaffold, but inside the scaffold itself, we have body. And for the body, then we're going to create a block consumer. So remember, a block consumer is the combination of a block listener and a block builder. We need a block consumer here, and the reason for that is upon every pressing of the plus or the minus buttons that we're going to develop soon, we want to clear the text inside of our text field. So that's a side effect. So by us saying that, okay, whenever there's a new state coming out of our block, we want to clear something. So this is a signal when you want to do a side effect that has nothing really to do with like a business logic or such, then that is your listener. So we're saying that we need a block listener, but also we want to, for instance, be able to have a builder. So we want to build our UI based on the current state of the block. Well, that is block builder. So if you need a block listener anywhere in your application and a block builder, you need to instead use block consumer if you need them at the same level. Okay, so block consumer combines block listener and block builder. So that's why we're using block consumer in this example. A block consumer is going to say, okay, what block am I operating on? So I'm just going to say you're operating on counter block. And then it says, what state am I operating on? And we're going to say counter state. Let's see if they're available. Counter state. And you can, I mean, I'm not making this up. This stuff is present in the documentation. If you go to block consumer as well, let's see in here what it says. It says extend state streamable. So that's the B here. B for me means the block and S is the state. So it's not so clear because it's working with a lot of generics, but you can read the documentation about that. Okay. So let's go in here, and in here, let's have a look. And it's complaining that some named parameters aren't present. As you can see, named parameter listener is required. So let's go ahead and say listener. And I'm going to get Visual Studio Code to help me clean this up. And upon any new events, or sorry, upon any new states produced by our block, I want to clear our text editing controller. So let's just say text controller. What do we call it? Do we call it controller? Yeah. So we're going to say controller clear. So we're going to clear the text that is displayed inside the text field soon. Okay. Then we need the builder function. So in this builder function, as you'll see, it will give you the current state, and you need to return a widget back. Okay. So what we're gonna do in this is, first we're gonna grab to see if there's an invalid value. So let's just say final invalid value is, and we're gonna say if the state is a counter state invalid number with a question mark. So we're using ternary here, and we're gonna say get the states. Let me bring the code up. Invalid value. Otherwise, we're gonna say empty string. So if I then in here say invalid value, as you can see, is now a string. Okay. And the reason behind this, to be honest with you, is so that we can basically display a little error message to the user should there be an invalid value. So if I have entered some information in the text field, instead of a number, I've entered hello world, and then our block produces a counter state invalid number, we're going to display an error to the user. And this error is going to disappear the next time actually the user enters a valid number in the text field. Okay, so we're going to use a new widget that we haven't used before called visibility. And this visibility is going to be based on whether there is an invalid state or not. So you'll soon see actually how we're going to implement that. So let's go, and as our builder's main return value, create a column. Okay, and column has to have children. All right, so what we're going to do is to first display a text field, a text in here. So let's just say text, and we're going to say current value is equal to this state.value. All right, so that's going to be the current value of our state. And if I do Command S, you can see that it says current value is 0. So that's the current value. Then what we're going to do is to go ahead and create a visibility widget, which in case the current state is counter state invalid number, is going to display an error message to the user. So let's say we're going to control the visibility of that error message using the visibility widget like this. And its child then is going to be a text that says invalid input. And then we're going to add the invalid value in here, as you can see, as we've constructed that up there already. And the visibility flag, you see, we have to return a Boolean. Okay, so how do we know that we have to display this widget with visibility? And that is if you can grab hold of your state and say, okay, this state is actually counter state invalid number. So let's just say state is counter state invalid number, just like that. Okay, so that's how we grab hold of that visibility. And you can see at the moment it's not displayed. All right, even if we put some, actually, let me just say is not, and then save it, and you'll see now it says invalid input. So it's just displayed right there. Okay, but if you say state is, then that is going to disappear because the current state is not invalid number. Okay, that was for visibility. Now let's go and add our text field, so where the user can actually enter some information in the UI. So let's just say text field as the first parameter. We're going to say the controller is our controller. Okay. And what we're going to do is we're going to give it a hint text. So let's say decoration is a const inputs decoration. Like that. I'm going to put the code a little bit higher on the screen. So for the hint text, I'm just going to say enter a number here, like this. Okay. And also let's just enforce the keyboard type, text input type of a number. All right. But also remember, if you, controller has not been initialized. Really? I thought we initialized the controller. Yeah, maybe you have to do a hot restart. There we go. So now we have enter a number here. Okay. Great stuff. Now, also, right, this is what I was going to say. Even though we have a text field here, and we actually said that a keyword should be numerical, but I can still paste non-numerical numbers in here. So if I like use the paste functionality in Android or iOS, so that's the reason we have that invalid state in case someone actually enters another value except for a number. And there are also input formatters in Flutter that you can use in order to, for instance, avoid users entering non-valid values in your text fields, but that's a whole other subject that we're not going to discuss in this chapter. So then what we're going to do is we're going to have two text buttons for increment and decrement. So let's, after this text field, create a row. So a row is like the opposite of a column, whereas a column displays its components vertically, one after each other. A row creates its components horizontally from left to right on left speaking languages and right to left for right side speaking languages, I believe. I think actually row changes its, it should at least change its, how it arranges its components based on the language, but I'm not quite sure about that. So let's say row, it has children, and it's two text buttons, okay, that have onPressed at the moment empty, and it's a child. It just says const text just minus like this, okay. So that's the first button. And then for the next one, I'm just going to copy this text button and I'm going to paste it right here. And in here, I'm just going to say plus. All right, so in here, when the minus button is tapped, I want to convey this information to our block. So I want to say grab the controller's text and make sure that you send this increment, where is it here? Increment event to the block. So we kind of need to grab hold of our block. How do we do that? The way to do that is using a convenient function that the good people at Very Good Ventures have created on context, and it's called read. And in here, you can actually say, I want to read my counter block like this. Okay. So this gives you access to your block that has been created by the block provider. So let's go ahead and in here, let's say after we read that, we want to add a new event to it like this. And we want to add an increment event that has the value of our controller.text like this. All right. So this is how you send events to your block. And the same thing is, since we're actually, sorry about that, this should be decrement. So let's just say decrement like that. And we copy the same code and we bring it to our increment function as onPressed button here. And instead of decrement, then we're going to say increment. Right? Perfect. Okay. So let's see now, let's test this application. So at the moment we have current value 0. Now, if I press the plus button, as you can see, it says invalid input. All right. But if I say 2 and press the plus button, you can see the value of 2 is entered there. If I say hello world here and press minus, then it says, oh, invalid input, hello world is invalid. And as you can see, it clears this text, and that's because of this listener here. This listener, because a block consumer is also block listener, remember? So it's a combination of a block listener and a block builder. So that's the clear working. And the part that is handling this invalid input is this thing, so visibility. If the current state is an invalid number, then this is becoming visible. But if the current state is not an invalid number, so let's say 3, 4 plus 2 is going to be 3, 6, then the current state is actually not an invalid number. The current state should be valid. It should be counter state valid. So then the visibility is hiding that error message. So that is pretty much it. I mean, huge congratulations if you could stick with me throughout this chapter. It was a very heavy, I understand, it was a very heavy and very like technical chapter, talking a lot about business logic. But believe me, if you didn't understand like most of the things I talked about, you just need to practice. I'm no genius. Nobody who knows how to work with Bloc or stuff like this is a genius. Everybody has practiced, put it into practice, done their own applications, done this test. Just go and create this counter application that I just created. Try not to look at the code that I've written or we've written in this. Just try to remember the stuff from your memory, and after exercise, practice and practice and practice, and you will get it, and you will get the idea of what a state is. You'll get the idea of what events are, what block is, and read documentations, and you'll get this eventually. I promise you that. As is tradition, we're going to now, since we're done with what we promised in this chapter, we're going to go and commit our code. So let me change the screen layout a little bit and go to terminal and increase the size, get rid of strcpy. And let's have a look at our log. Last chapter, we committed step 21. So let's see git status. And there were just a few things changed. So let's add everything and just say git commit step 22. And let's push our changes. And then I'm just going to say git commit, git tag to see our last tag. And I can see it was 21. So let's tag this as step 22 and say git push tags. There we go. So now step 22 is also tagged and ready. So what is to come? This is also a tradition we have. At the end of every chapter, we talk about what we need to discuss in the next chapter. And what we need to discuss in the next chapter is, and we will convert our auth process to using Bloc. So we've now talked, we actually got our auth logic inside our application, and that was our auth service. I don't know if you remember from before, but we need to convert this auth service to Bloc. And so in that way, we're actually putting our knowledge about Bloc into use and combining it with what we've already developed to make our application better and our logic not so spread around everywhere in the UI. So if you want, grab some refreshments, tea or coffee, and I'll see you in the next chapter.